Welcome back to Learning Analytics Tools course. This week we will continue on predictive analytics. So, we will discuss naive Bayes classifier and additionally classification algorithm in this week. So, naive Bayes classifier is a probabilistic classifier. The output will be probability of getting pass is some probability 0.7 or 0.8 or 0.2 or 0.3, and it is very widely used in test categorization. So, it is one of the supervised algorithm because we have to give the label also, not only the x, we also have to give the y. So, we know what to be done, like a classification, whether you have to predict pass or fail, or you have to predict whether the student will continue in the course or not, something like that. So, it is based on Bayes theorem, that is why it is called naive Bayes. So, what is naive? There is a naive assumption here, that is very important in the Bayes theorem. Bayes theorem is very simple, you might have used it in the probability classes, but this naive Bayes classifier assumes a naive assumption, that is the features occurring in this are independent, that is the main assumption. Suppose if you try to model the students performance based on their attendance, assignment, submission or some engagement in the class, there is something you have to assume that these occurrences are independent. Okay. Although it is not possible, the student has to be attending the class to improve the engagement, but the naive Bayes makes this assumption, that is a naive assumption. So, you can think of other features like in MOOC, a student logging in, student interacting with the forum, student watching video, these are independent because not every student is going to interact with forum or something like that. So, this assumption is the naive assumptions in the naive Bayes theorem. So, let us start with the activity before we jump into what is naive Bayes theorem. Let us see what is conditional probability, just to brush up your memory. So, there are two independent there are two dependent events A and B. If two events are dependent given this kind of diagram, what is the probability of A given B, that is what the probability of A occurring given B already occurred. Can you write down the formula for conditional probability? You know this Venn diagram, intersection, joint, all those things. Can use that just to write the conditional probability of this two events, two dependent events. So, Bayes theorem starts with this conditional theory, that is probability of A given B is probability of A and B occurring together given probability of B occurred, like a probability of complete B and the joint probability of A and B, that is a Bayes theorem. For example, if I want to know probability of student will fail the exam if attention is low. So, that means probability of failure and attention low has to occur. The student who are have a low attention also failed in exam, a lot of other people might have failed, plus given that the probability of B attention occur, there is a probability of attention. So, let us see this in a detailed conditional probability. Let us look at the example. This is a standard probability sum. There is a box which contains 4 apples and 3 oranges. Out of this 2 apples are defective and 1 orange is defective. Okay. What is the probability if you pick a defective fruit, that fruit will be a apple. To identify it, you can apply a conditional probability. It is very simple, it is very simple to answer directly. Let us see what is the probability of apple and it is being defective and probability of defective fruits. So, let us since it is a complete divided by all these fruits involved, I am just going to completely ignore everything. I am just going to simply apply apple and defective is 2 and the total defective fruit is 3. Okay. There are 3 fruits available defective. If you picked one, it will be 1 among 3, and how many of them can be apple is 2 out of 3. So, it is very simple probability, okay, 2 by 3, because you do not need to even think of much. There are 3 fruits, 3 are defective, that is out of 3 how many will be apple, like a 2 out of 3, that is 66% of chances that fruit will be apple, or 0.66 probability. Let us look at the Bayes theorem from the conditional probability. Probability of A given B is probability of A and B, that is equation 1, that you can write it, that you saw that in the previous slide, simple. And probability of B by A, that is probability of A and B, same, right, because B by A, but probability of A. If I want to replace this term, with the other term. Suppose consider this probability of B by A, this term can give probability of B by A into probability of A. This is equal to this, right. I mean, like, this particular term can be kept and these two can be removed. Okay. This can be this, like, probability of A and B, sorry. Probability of A and B, right. This is exactly so. So, you can replace this particular statement by this value. So, that is probability of A by B equal to this P of A and B can be replaced by this particular term, probability of B by A into probability of A divided by this P probability of B. That is very simple, right. So, just have two equation, you just have to apply that, that is called the Bayes theorem, that is it. This is the simple Bayes, this is a Bayes theorem, and you have a naive assumption on it that we can use as a naive Bayes classifier. That is exactly this equation is going to explain, yes, probability of A by B, or in a Bayes theorem it is exactly the same value. So, Bayes theorem is very simple, it is just a two conditional probability, it is like a probability of what a probability of that A will occur given B already occurred or gives some value of B is probability of B by A into probability of A divided by probability of complete B, like not just the particular probability of event occurring, all the possibility of event occurring, if it has 3-4 values, all the values to be occurring together. Okay. That is a Bayes theorem, a simple Bayes theorem can be derived from the conditional probability. You might have already known that, but for people who do not know, just this is brushing up what is Bayes theorem. So, now even this particular question also can be solved without using Bayes theorem, but I want to apply a Bayes theorem in this. Consider a couple has 2 children, they are not twins, okay. One of which is boy. What is the probability that they have 2 boys? Okay. They have two children, boys or girls, anything possible. So, boys, girls, boys, girls, something like that. Consider one of which is boy, say first child is boy. What is the probability that they have 2 boys, second child also boy, something like that. Please write down the answer. After writing it down, I will assume to continue. So, how do you do that? If I want to do solve it via Bayes theorem, first I need to understand what is the question. So, the question is probability of both children are boys. We want to predict this, right. What is the probability they have 2 boys, right, and given one of them is boy, right, one of the child is boy. So, we have to predict probability of A given B. Okay. What is the probability of both children or boys given there is one children might be one children is boy. So, that is probability of A given B. You can simply apply in the Bayes theorem and the probability of A by probability of A into probability of B by A into. So, how these numbers came? These numbers are very simple, right. So, probability of both children are boys, there is only 2 possible, right. So, child 1, child 2, first possibility is both are boys. Second possible the outcome, the outcome space, right. The outcome space is one is boy, first child is boy, second child is girl. Third is first child is girl, second child is boy, fourth is both childs are girl. Okay. So, the outcome, the event space is only this 4 events possible, you know, and I said that there are the first one and second child and not twins, all these things I gave. So, given there are 4 possible outcomes, in that being both are boys is 1, okay, that is why it is 1 by 4, this is actually this being both are boys, okay, it is 1 by 4. Probability of being one of the child being boy, it's like here at least one child is boy, this one child is boy, and here also one child is boy, at least one child is boy. Out of 4, the 3 times there is one child can be boy, it is simple, right. So, that is answer here. So, 1, 2, 3, 3 chance that at least one of them will be boy. So, now we have to compute this. So, probability of A is, you know, probability of A is 1 by 4, true. The tricky part, you know, the tricky part is this one, probability of B given A. What is B? B is probability of one of them being boy given probability of both our children are boys. This is a tricky part, you might have missed. If you would have answered correctly, that is correct. If you would have missed, this is the exact tricky point you would have missed. The point is probability of B by A means one child is equal to boy given both are boys. You know, both are boys matlab definitely one child will be boy, right. So the probability is 1, simple as it, that is a 1 actually. If you substitute that, the answer will be this. As I mentioned, this you do not need to use the Bayes theorem to solve this problem, but I took the simple problems to explain the theorems here, because that you can understand step by step. So you can solve without applying the Bayes theorem, that is fine, but this is how you can apply Bayes theorem on this kind of problems. Please go ahead and solve more problems related to this probability based problems in the internet and understand how it works. That helps a lot to understand Naive Bayes theorem. Naive Bayes theorem is just this Bayes theorem only. So, we saw what is Bayes theorem, not the Naive Bayes classifier in this slide, but it is a Bayes theorem, how it is constructed from the conditional probability, and I request you to go to solve much more probability problems using Bayes theorem. Thank you.